Hi folks, my name is Arya and I welcome you all to this video on blockchain applications. So this is going to be one of the most preliminary videos in the blockchain application development playlist. And in this video, I'll be explaining how the development of decentralized application actually takes place. And then in the end, we'll be going through some of the most popular decentralized applications that are using blockchain tech. Okay, so let's get started. So first of all, we're going to be taking a look at the traditional way normal applications or web services work. So firstly, a web service has two parts. Firstly is the client, and then the client connects to the web server. Now this web server is very centralized and it's owned by a certain company that is actually hosting all the web services. So anytime you want to use any of the services hosted by this particular company, you have to send a request to their server, in which the response they will give you the requested service. Now, what does this centralized server actually contain? Well, it contains two major things. Firstly is the API, and secondly is the data. Now, the API is mostly all the services and all the endpoints that are actually being served by the hosting service. That may be any company like Facebook, Google, Twitter. And the second part is the data part. Now, this is the most important part for you as a user, because any of the data that you are also creating, that is user-generated content, is also being stored on their centralized architecture. So what does this actually mean? Well, when these two things are actually being owned by big major companies, they have the right to do anything with your data. So however, they may be advertising your privacy protocols, like Facebook says that they will never use any of the user-generated content for their own business. But that's kind of not true. Facebook earns a lot from ads that is actually being directed towards you because of the interest that you show on Facebook. So if you show some interest on clothing, you'll definitely get some ads related to clothing. So how is that not using user-generated content for their own purpose? Well, some of you might not agree with this whole agenda of privacy and how it works. Well, you don't actually need to, because the main problem out here is that it's a central point of functionality. So if a hacker actually wants to penetrate through to their system, he only has to actually concentrate on one point, and that is the main server. So if that is actually hacked or somehow compromised, all your data, all the APIs and all the endpoints, everything is compromised in a process. So this is how traditional applications works, and these are the shortcomings that come with the traditional applications. So the invention of decentralized applications mostly promised to deal with all the problems that come with the centralized architecture. So let's see how a decentralized application actually works. So firstly, you have the user who invokes a smart contract. Now, if you don't know what a smart contract is, you can check out my smart contract tutorial, where I've told you all everything that you need to know about smart contracts and most of its development part. Now, the smart contract will contain all the rules abiding for the service that is being provided, and it also contains state information which contains data for the smart contract. Now, you must be also thinking that in a centralized architecture, the hosting and other peripherals is taken care of by the hosting company like Facebook. So when you are going on Facebook server, you do not actually have to pay for any computation because Facebook is doing that already. Now, Facebook also takes a part of your money and repeat. Now, Facebook also takes a part of your data and converts it into more profit, but that exactly doesn't really happen in a decentralized network. So how is computation being paid for in a decentralized network? Now, the computational resources that is required, it is paid in gas, which is the unit that is used in the Ethereum network. I'm going to be using the Ethereum network for per se as an example. So gas is the way you pay for resources when you are using a decentralized network. Other than that, you're also paying a small amount of fee called a transaction fee. Now, this transaction fee is actually collected by the miners who are validating these blocks. This transaction fee can actually vary from around 1 or 2 Ether or even its smaller denominations. Now, every miner who validates a block also gets paid by the network in terms of Ether. So every miner probably gets around 1 to 2 Ethers nowadays. And every block only takes 14 seconds. So that's how currency is also being generated in the network. Now, what happens next is all this money that you need for your transaction is being fetched from your wallet, which is your Ethereum wallet. Now, your Ethereum wallet is used to manage your funds and invoke different contracts. So that's all you need to keep in mind when a wallet is told to you all. Now, after all this invocation has been done, and all the state changes have been made and the miner validates the block, all this information is then sent to the network, and the network then updates your wallet with the new and updated funds that you have. So this is basically how a decentralized application works. You are going to invoke a smart contract. Now the smart contract changes some stuff on your account, and all these resources that you use are paid for you and by the network itself. So you're basically not depending on anybody else. Now let's see the technology stack that is normally used in the development of decentralized apps or dApps. So the front end is made mostly using the normal way, that is HTML, CSS, and JavaScript. But you can also use any of the majorly available frameworks like Angular, React, Vue.js to actually create your front end, because your front end will be interacting with the smart contracts through the Web3 API. Now, the Web3 API is what lets you connect to the smart contract that is residing on the decentralized network, and the decentralized network can also talk back to your application through the means of events. We'll be talking about events when we get into the app development part in future videos. But for now, all you need to know that smart contracts are written in Solidity, and the front end is written however you want to wish, actually. Now, Web3 is available in JavaScript, Java, Go, and Python. And we'll mostly be referencing the JavaScript part, that is the web3.js. So we'll be using web3.js when we're actually developing some kind of app in the future. So don't forget to check back in. Now, let us just go over the advantages of decentralized applications or blockchain applications that come along with it. So firstly is autonomy. So it's autonomous because you're the one making the agreement. There's no need for a broker or a lawyer of any sort or any sort of third party for that matter. Secondly, there's a lot of trust because all your documents are encrypted using modern technology and modern encryption methods, and it's all sharded and distributed on a decentralized network, which is being run by a shared ledger. So there's literally no way anybody can break into it, now at least, unless quantum computing becomes a very big thing in the next 6 months or something. Thirdly is backups. On the blockchain, your documents are duplicated many and many times over. Your documents are owned and seen by everybody on the internet, but in an encrypted fashion. So you do not need to worry that, oh, somebody has my copy, so they might be able to see it. It's not like that. It's all encrypted and only you can see it. But a copy does exist. So in case you actually lose some of it, you can always go back and check your transaction IDs and get back what you just wanted. Last but not the least is accuracy. Now, whatever these smart contracts are trying to replicate, so things like bidding, form completion, and such things, mostly done by clerical workers. So most clerks actually tend to make a lot of mistakes because this work is generally very tedious manual work. But since we're talking about computers, there is no chance for any sort of mistake unless there's bad code, in which case it's normally a bug which is fixed by the developer in no time. So accuracy, backup, trust, and autonomy. These are the major advantages of decentralized applications that is severely lacking in most centralized architectures. So now that we've seen how decentralized apps work in comparison to traditional apps and the advantages of using a decentralized architecture for most service providing apps, so let's go ahead and see some of the most interesting decentralized applications or applications running on the blockchain that have been developed till date. So firstly, we have BlockVerify. Now, one of the most significant problems that the business community faces globally is counterfeit products. These counterfeit goods and products lead to billions of dollars in losses every year. However, the blockchain could offer a solution to these issues. BlockVerify is a project that seeks to harness the blockchain to fight the counterfeit industry. With the blockchain, BlockVerify is confident that they can monitor the entire supply chain with complete ease. According to those behind BlockVerify, the only way to improve anti-counterfeit efforts is to utilize the blockchain. To achieve this, they are using a private blockchain which is highly scalable, transparent, and tamper-proof. Every product will be given a unique identification number that is then stored on the tamper-proof blockchain. So basically, BlockVerify can help you identify counterfeits, non-duplicatables, company verifiables, and it also offers a global solution in the method. Now, anyone can be able to access this number on the blockchain to verify whether a product is genuine or not. So with the solution, things such as medication or anything else can be verified with ease using this solution. Anyone can be able to conduct the verification utilizing this technology. So what all can BlockVerify do? Well, it can help you identify counterfeit goods or diverted products or stolen merchandise and even fraudulent transactions. Okay, so that was all about Block Verify. Moving on, we have Ripple. So RippleNet is a network of institutional payment providers such as banks and money service businesses that use solutions developed by Ripple to provide a frictionless experience to send money globally. So let's give an example first. So firstly, imagine there's a Mr. Jones who lives in New York and has a box of chocolates that he doesn't really need. Now he's very interested to watch a baseball game but doesn't have money for the tickets. Secondly, there's a Mrs. Smith who lives in Los Angeles and has a rare stamp and she would like to give away for a box of chocolates. Lastly, we have a Mr. Brown who lives in Alaska, suppose, and he's looking for a rare stamp and he has a ticket for a baseball game in New York that our Mr. Jones is very much looking for. Now, in our current system, these people would probably never find each other and remain with their not valuable valuables. But in the Ripple world, they could say, hey, I have a box of chocolates and I want baseball. And the system will look for a shortest and cheapest combination to make it happen. Moreover, the platform allows you to make payments in any currency, including Bitcoin, and has a minimal internal transaction commission of around $0.00001. Yes, that's the right amount of zeros I just said. And the only reason it's not free is to only prevent DDoS attacks. So the current system for transactions is pretty much unreliable, expensive, and slow. Unreliable in the sense that a transaction can take days to actually get committed to the bank. It's expensive in the process as to how many people you need to pay to get your transactions done. And it's very slow as a whole overall. Now, what Ripple does is it promises to actually remove all this by making transactions very much accessible. Like I just said, that you can exchange cookies for a baseball game, something like that. And it's very, very fast. Oh my God, Ripple is amazingly fast. You have no idea how fast Ripple can be. Secondly, because it runs on the blockchain, of course, it's reliable. And as I just said, Ripple has some insanely low costs. And it's only not free and low cost because we need to prevent those DDoS attacks. Up next on our list of blockchain applications is 𝐓𝐶𝐗. So 𝐓𝐶 is an open source decentralized file storage solution. It uses encryption, file sharding, and a blockchain-based hash table to store files on a peer-to-peer network. The goal is to make cloud storage faster, cheaper, and private. Now, the traditional cloud storage solutions like Dropbox or Google Drive has limitations. While files are backed up redundantly, bandwidth from a data center or unexpected outages can restrict access to your files. There's also this issue with privacy, and these companies have control over all your files, including the ability to access them. Now, the 𝐓𝐶𝐗 project uses blockchain and peer-to-peer networks to solve these problems. It distributes the files so redundancy is well established. It also guarantees you're the only one who can access the files because of the encryption. Now, the best place to understand 𝐓𝐶𝐗 is probably torrents. Now, in the near early 2000s, torrents became a notorious way to download movies, music, TV shows, and use them for free and illegally, of course. Now, torrents use a peer-to-peer network, and it works something like this. Mainly, users maintain copies of the same file all over the network. When someone wants a copy of that file, they send a request to the peer-to-peer network, and users who have the file known as seeds send fragments of the file to the requester. The requester receives many fragments from many different seeds, and the torrent software recompiles these fragments to form the original file. Now, the benefits of using a torrent is you can download fragments of a file from multiple sources in parallel. So this means the file transfer could potentially be faster than the downloading and the whole thing all at once from a single source. Additionally, for the purpose of pirated music and videos, torrents are decentralized. No company controls the torrent, so it's difficult to shut down a torrent. And the same could be said for 𝐓𝐶𝐗, but you can't say the same for Google Drive. So 𝐓𝐶𝐗 works in a similar way, except it's not for pirated music and videos. So let's take a moment to understand that. Firstly, there's some end-to-end encryption going on. This is where the data privacy goes to the next level. Sharding already adds one layer of privacy as no one knows which data to host and can read the whole file from, but even being able to read a shard of a file is problematic. It could still contain some sensitive information. So what exactly is file sharding? Well, the first way 𝐓𝐶𝐗 is similar to torrents is sharding. So this means your file is broken up into millions of pieces and distributed on a network. So that is where the distribution part comes in. And the fourth part is audit or file verification. So to answer this concern, 𝐓𝐶𝐗 completes a file verification audit every hour. In order to get paid, farmers or the people who are validating on the network have to prove that they have the shards they've been sent. Storj sends a request to the farmers, and if the farmer has changed or deleted the encrypted shard, they won't be able to answer the request. So that's a pretty neat way to actually approach cloud computing and cloud storage using blockchain applications. So next up on our list of blockchain applications is 𝐸GR. So 𝐸GR is a decentralized prediction market which can forecast the outcome of an event based on the wisdom of the crowd principle. So basically, it's a prediction market protocol owned and operated by the people that use it. So with this method, information collected from the crowd is averaged into the most realistic possibility and therefore the most probable outcome. Correct predictions are rewarded by the network, while incorrect, reported and penalized. And this incentivizes the truthful reporting of events. So 𝐸GR aims to revolutionize the prediction market, and in doing so, changing the way people receive and verify the truth. Now, the main idea is to make more accurate predictions by large groups of people rather than a small team of experts. So 𝐸GR is also the first major decentralized application developed using Ethereum and represents a major proof of concept for this underlying technology. Decentralization ensures that 𝐸GR cannot be censored by governments that deem prediction markets as gambling, whilst ensuring the sustainability of the application. This decentralized nature ensures honesty in reporting an outcome of events using crowd wisdom to cancel out individual frauds. Now, 𝐸GR has been used for weather prediction, political forecasting, event hedging, and even company or business forecasting. And it's going pretty well in my opinion. So how exactly does 𝐸GR work? Well, 𝐸GR works on events. So an event occurs that is being wagered upon in a market created on the 𝐸GR network. Now, the outcome results are reported by the reputation holders to 𝐸GR in 2 steps. Part 1 of this step is the reputation holders privately and securely submit outcome results to the network. And the part 2 is that about 1 month later, a second report is publicly submitted in plain text for all to see. Next, upon completion of reporting periods, consensus is achieved, leading to 2 financial events. Those who wagered correctly are paid out for their predictions, and honest and active reporters receive trading fees and proportionate with reputational holdings. And on the other hand, dishonest and negligent reporters lose a lot of their reputation points, which is redistributed to honest and active reporters. So this means that rep is only necessary for those wishing to report and not for those just wishing to wager. So all reputation tokens are available in the reputation software sale, and you can check them out at 𝐸GR's site. Now, the last application that we're going to talk about is going to be something for you guys who are looking for jobs. So firstly, this is called 𝐸𝐺𝐺. Now, 𝐸𝐺𝐺 allows you to create an employee or employee profile and list and apply for open positions, ranks, and provide feedback for employers and employees, and send and receive invoices. Now, 𝐸𝐺𝐺 works on the Ethereum, and so it basically has 0% service charge, is decentralized, and there's no restriction, and has free membership. So something like freshersworld.com, where you are applying for jobs as a fresher, you mostly have to pay a certain amount of fee so that you get those invitations and interview call letters. But on 𝐸𝐺𝐺, you basically don't pay anything, and you are getting the best contacts as a freelancer. So basically, 𝐸𝐺𝐺 is a first of its kind in the job market platform for connecting freelancers and developers with employers. Its database runs completely on the Ethereum public blockchain, and front-end source files are distributed on IPFS, or the Interplanetary File Storage System, meaning 𝐸𝐺𝐺 is fully decentralized. So basically, there's no cuts and only savings. 𝐸𝐺𝐺 doesn't take a percentage of what you earned from the connections that you made on 𝐸𝐺𝐺. And the amount of ether that the employer pays is the amount the freelancer gets. So that's a very, very big thing for freelancers. Next is there are no artificial costs or restrictions. For example, let me just quote Freshers World. So Freshers World says that you can join for free and you'll get all those interview letters. But that's actually a sham, because you will be needing to pay that really pro version payment option that they have. So you will have to buy that if you want to get those premium companies calling you for your CV, even though you might be actually a very good coder. So basically, everybody can apply for a job on 𝐸𝐺𝐺 or create an unlimited number of jobs. All that is needed is to pay for the gas fees that is associated with these operations. Okay, guys, so in the end, we saw how decentralized applications are developed, the technology stack that is used, basically HTML, CSS, Web3 API, and Solidity, and how decentralized applications compare to traditional applications. And then we saw a few very good examples. In the upcoming videos, I'll be teaching you guys how to create your very own simple decentralized application by interacting with the Web3 API. So please hold on your thoughts for those. That's going to be all for now. Goodbye and have a good day.